Hi students, we're looking at graphing polynomial functions, note section 2.9, and these are a lot of fun. We are going to combine the shapes of our smaller degree functions to make one large mega function. So remember our degree 1, that's y equals x, and that has the shape of a line, and I'm not going to draw the y-axis, and it just looks like this. And so if this is the x-axis, I'm going to call this shape or refer to it as a chute. Like chutes and ladders, it's kind of like a slide. It just slides right down through. For our degree 2, that's y equals x squared, and that has the shape, again, not drawing the y-axis, where it passes and is tangent to the x-axis, right? If there's no k value, that's what it looks like. And since it doesn't pass through, it's almost as if it bounces off the axis. Of course, a bounce really looks like this visually, but I'm still calling it a bounce. And then for our degree 3, we've got our x-axis, and it's going to slither through, right? Close enough. That's y equals x to the 3rd power, and that point of inflection I'm calling a snake, because it's a little bit fun. So we can refer to these different shapes based on how they appear visually. Another important thing about these polynomials is the end behavior. So remember, with an odd degree, that's going to be our linear function or our cubic function, and they both have the same end behavior. And so remember, this is quadrant 1 with positive x and a positive y. This is quadrant 2 with a negative x and a positive y. This is quadrant 3 with a negative x and a negative y. And then this is quadrant 4 with a positive x and a negative y. So these ones have they have the same values, but this is not considered same end behavior. It's just that it's technically, as x goes towards negative infinity, right? Here's negative infinity for x. Whereas y? Well, y is also at negative infinity. And then as x goes towards positive infinity, where does y go? Well, y is going towards positive infinity as well. Looking at an even degree function, that's pretty much our parabola. And here we're in positive, positive, and we're in negative, positive. So as x goes towards negative infinity, y goes towards positive infinity. And as x goes towards positive infinity, y goes towards positive infinity. What about if we have a negative a? Well, that's like a slope of -1 on a line, or the cubic function looks like this. So this is going to be negative x, positive y, positive x, and negative y. And so as x goes towards negative infinity, that's the x, we've got y going towards positive infinity. And as x goes towards positive infinity, y goes towards negative infinity. So we do say that this is opposite end behavior because for each of these odd degrees, the x is going towards, the y goes towards a negative and a positive, or in this case, a positive and then a negative. Versus we sometimes say that the evens are same end behavior because the y value was going to positive infinity and then again positive infinity. The y was going in the same direction. So when I think of a parabola that has a negative a value, it's also facing down. And so that one is negative, negative, and then positive, negative, meaning that the as x goes towards negative infinity, y goes towards negative infinity. And as x goes towards positive infinity, y still goes towards negative infinity. So the y is again going in the same direction for both sides of the graph. So sometimes we refer to that as same end behavior, because the y values go in the same direction. Not odd where the x and y do the same thing for a positive a value. Okay, so then in order to get an accurate graph, we plot the x and y intercepts. And so let's take a look at this function. Number 1 here is in factored form. So what we're going to do first is find the x-intercepts, plot them. We're going to look at the degree, the number of turning points, and then we're going to notice if each one has like a significant piece of information. So my x-intercepts. So here, remember we use our zero product property. So then I just have x equals 0, that's still 0, 0. And I'm going to just do that work right here. Then I have x plus 8, and that's going to, these are both going to be a shoot because they are at degree 1. But then this one is a degree 2. So what shape is that going to make? A bounce. And so I'm going to have my other x-intercept at, okay, x plus 8 equals 0, negative 8 plus 8 equals 0, so x is negative 8. And then this last one, x minus 2, so that's going to be 2 minus 2 is equal to 0. Because remember, we're trying to get 0 inside the parentheses. So I'm going to begin by plotting these ordered pairs. I wonder if it's going to allow me to plot them. Okay, challenge level accepted. Okay, so I was able to plot those x-intercepts. I'm now going to look at the degree. So I'm going to count up how many x's there are. This is 1x. This is another x, so that's 2. And then this x counts as 2 more. So this is a degree of 4. When it's a 4th degree, that means that there will be 3 turning points. In this case, the a value is positive 1. And so for an even degree with a positive a value, let's see, even degree with a positive a value, we're going to go to positive infinity and positive infinity. So I'm going to sketch my end behavior and sketch my end behavior. And then I'm going to notice that I'm just going to pass through these other ones. And then at this one, I'm going to have a bounce. So I'm going to draw it like this. And then this one, I don't need to sketch the other ones specifically. So in order to make the end behavior work, I actually need to sketch it like this. And that will be my function. Oops. It looks like I have to kind of fudge a little bit to make it work. Oh my gosh, I'm getting better. Okay, so it's supposed to bounce at this spot. I don't know what to do about that.